Hello everyone, welcome back. So now we're going to take a look at creating the specular effect on the foam, and this is the final render from this scene, and we're going to set it up together. And you see here we're adding the specular component, and let's see how to do that. So everything we shade and render using Mantra in terms of geometry, it has normals, and most of the calculations happen based on that surface normals. When it comes to volume, there is no such thing. So we have to provide or fake this normal information. And the easiest way to create normals on volume is by analyzing the volume and computing something called gradient. What gradient is basically it's going to give a vector that starts from one point and try to reach the limit of the volume, which is called the isosurface. And so this gradient information is basically a normal but for volumes. And the easiest way to compute this information is by using a VDB analysis node. And by default the operation is set to gradient. You can see it expects a scalar and it produces a vector, and we wanted to make sure that it runs on the density, and I want to change the name of this field to gradient. Okay, and then I'm going to merge this. So this gave me a new field. Let me lower the volume so it's faster to work with. Gonna increase the voxel size here, and this is our volume gradient, and it's a vector field. So let's connect the density from before and merge them. So now we have two fields, and let's do a few things on the shader side. So I've done this before, but I'm gonna delete it. So we go back to the original state. So this is how it was before. OF and CF, and this is a great. This shader is working great with volumes, and it's giving us the look that we want, the volumetric look. But to get the specular, we need to use a surface BRDF, and that node is PBR reflect, PBR reflection. It's a PBR non-metallic, and we're going to leave the default options, everything to the default. And here you see this base node. We can use this to layer other BRDFs, like the volume one. So I'm going to copy the volume into the base, and then this node expected to work with surface, with geometry, and in that case it has all these inputs like the normals and the normal for the NL vector, and it knows how to do all the calculation. But in the volume case, it doesn't know what the normals are, so we need to provide that. And I'm going to use a parameter node, and we want to read the gradient attribute. By doing this, it's going to stream in the field called gradient, and by default this gradient is inverted, so we need to negate this information. And let's make sure it's set to vector. We need to negate this, and then we need to normalize it to make sure that the range is correct. And then I'm going to plug this into the NN, and then I'm going to feed this here. And for the OF, it's going to continue coming from this node. So that's for the opacity of the surface if we decided to use something else. And I'm going to increase the roughness so it's not super sharp, the reflection. And let's do a quick render, see how that looks. So it should be starting in a few seconds. There is an error. Let's see. What's the error? Nope, there's no error. It just needed a few seconds for it to come up. And sometimes I get this weird issue for the viewport. It's just M-Play acting up. Okay, so I've already done the render, so I hope it's not confusing. This is, let me remove this. Yeah, I didn't remove it from here, but it's running now. So I'm gonna click here because this area shows the most amount of specular. And we can increase or decrease the roughness. The bigger the roughness, the blurrier the specular is going to be. And we also lower the volume resolution so we have less details. It's going to look a bit blurry. And this is the previous result without any specular, and this is with the specular added. So that's how you compute specular on volumes. The only thing that we may want to do is if we look at if we look at these areas, they're capturing specular, we may want to blur the density here. We could add, I haven't tried this, but just an idea, VDB reshape, VDB blur. There is a VDB smooth. So we can smooth out the voxels just a tiny bit. Yeah, see, there's 0, 1, and that's going to smooth the result, obviously, but we'll make all these speculars go away because we don't want it to be too sharp. Like, we wanted to see it here, but that's about it. And that's pretty much it for